Okay, this is a problem that involves Newton's law, and we have two blocks, this block A and this block B, that are connected along this cable over a pulley, and we're asked to find a few things. We're asked to find the acceleration of A, we're asked to find the acceleration of B, and we're asked to find the tension in the cable. So the first thing we should do, this is a pulley problem. We can dimension our pulley like we've done with all other pulley problems, and we reference down to each of the moving parts. Part A, we'll call it S sub A. It's this length right here from the pulley to however long this cable is to block A, and we want to dimension down to this block B. This will be S sub B, and this will be whatever length of cable is from the pulley down to block B. From this dimension, we can get a few important pieces of information. We can note that our positive direction is now down. It's not up, it's down because we've referenced from our datum down. And this becomes very important later in the problem. Second, we can figure out the length of the ropes and the velocity and acceleration parts of the relationship between these two blocks. So if we have the length of the rope, we go up, it's S sub A. We ignore this part over the pulley right here because it's constant, and we come down, and this is S sub B. So we have S A plus S B is equal to some length of rope. If we derive this, we take the derivative with respect to time, we get the velocity of A plus the velocity of B is equal to 0. Why is this 0? This is 0 because this length of rope right here is a constant, and when we take a derivative with respect to time of a constant, or when we take a derivative of a constant, we get 0. So if we derive this again, we get the acceleration of A plus the acceleration of B is equal to 0. So we have the acceleration of A is equal to the minus acceleration of B. And now we want to figure out what the accelerations of A and the accelerations of B and T are. And we have our first equation to do that. To get our second equations, we have to look at Newton's law. And Newton's law is the sum of the forces in the y direction is going to equal a mass times an acceleration in the y direction. Okay, so let's look at block A. Block A, if we draw our free body diagram, we have a weight coming down, which is 10 pounds. We have a force coming up, which is this tension in the rope. And if we draw the other side of our free body diagram, we draw our kinetic diagram, we have a mass M, and let's do it this way. Let's call it 10. And because this is pounds, we want to divide it by gravity. And when we were working with English units, we divided by gravity to get a mass. And we are going to also have an acceleration. And this acceleration, we're going to assume the acceleration of A, and we're going to assume it's in the positive direction, so it's going down. When we make this assumption, it's a lot easier just to assume it's moving in the positive direction rather than where it actually might be moving. It might be moving up. But if we are wrong with our assumption, there will be a minus sign to straighten everything out at the end of the problem. And now let's make a free body diagram of this 20-pound block. And so we have the 20-pound block. We have a force coming down, which is 20 pounds. We have a force going up, which is T. It's connected by the same rope, so this T is the same as this T. And if we equal this to our kinetic diagram, we have our mass, which is 20 divided by G, times the acceleration of B. And we're going to, again, assume it's in our positive direction, which is going down. So now when we sum our forces, we have the sum of the forces in the y direction positive is down, so sum of the forces in the y direction is equal to a mass times an acceleration in the y. And from this equation we get 10 minus t is equal to 10 over g times the acceleration of a. And with this free body diagram, we get 20 minus t is equal to 20 divided by g times the acceleration of b. And these are the three equations we want to use. We want to use this first equation that relates our two accelerations, this second equation, which is the sum of the forces in the y for this our block A, and this third equation, which is the sum of the forces in the y for block B. And if you notice, we have three equations, and we have 1, 2, 3 unknowns, so we should be able to solve for all of our variables. And in fact we can. So let's solve for t, and we get t is equal to 10 minus 10 divided by g times the acceleration of a. And let's put this equation into our acceleration of a, so we get t is equal 10 minus 10 over g times a negative ab. Okay, so let's substitute this t into this t right here, and when we do that, we get 20 minus this t, which is 10 minus 10 divided by g. I'm actually going to distribute this negative sign with the AB right here. So I get this equation right here. And this can be further simplified. So we have 10 minus 10 over g times AB is equal to 20 over g times AB. So 10 is equal to 30 over g times AB. And AB is equal to 10.73. This is feet, so it's feet per second squared. And this is our answer for what the acceleration of AB is. And we should notice that this 10.73, it's a positive 10.73, so that means our assumption that it was moving down is correct. So this 10.73 is moving down. Now right here, we know that the acceleration of A is going to be equal to the negative acceleration of B, so it's equal to minus 10.73. And we know that this minus sign means this assumption was wrong, and it's actually moving in the upward direction. So the acceleration of A is moving 10.73 feet per second squared in the upward direction. So this is we'll keep it with a minus sign. So the acceleration of A is minus 10.73 feet per second squared. The acceleration of B is 10.73 feet per second squared. And what is tension? Well, we can right in here we can plug in our answer for the acceleration of A, and we can get the tension is equal to 10 minus 10 over g times minus 10.73. And I think I forgot to mention this, but you might have followed along. Gravity is what this g is, and gravity is going to be equal to 32.2 feet per second squared. Sorry if you weren't following what this g was. But if we solve this out, we get a t is equal to 13.3 pounds. And that is the last thing that we were looking for. So this is the answer of this question.